Good morning, students. I, Jeevan Kumar Pandey, welcome you once again to the second lesson for the chapter motion of standard 9th. Students, last class we discussed about three main concepts: position, path length, and displacement. I hope you have revised the things. In continuation to that, today first we will discuss two things. First, average speed and then average velocity. Average speed is defined as the total distance covered divided by the time taken to cover that distance. And how will you define it? So average speed you can define as the distance covered per unit time. How do you find that? Total distance divided by time taken. Likewise, average velocity we will define as, it has similar formula. Just as speed is related to distance, the velocity will be related to displacement. Now distance is same as path length, if you remember. So this will be the this will be the displacement divided by time taken. So these are the definitions for average speed and average velocity. So if you know the path length or distance and displacement, you can calculate them. Let us see their units. Distance, if you remember students, I have told you to remember three units for length, mass and time. Distance is length, so its SI unit should be how much? Its SI unit will be meters. Time, its SI unit will be what? Second. Therefore, SI unit for average speed will be how much? Meter by second, which we will write as ms to the power minus 1. Can you guess the unit for average velocity? Of course, since displacement is also a kind of length, its SI unit is meter, its SI unit is second, and therefore SI unit of average velocity is also meter per second, or ms to the power minus 1. Having understood this definition for average speed and average velocity, let us try to see one example to understand it better. Now see, this is a question, the first question that we will discuss. Here you see a number line. You can assume it to be a straight road. A body starts from point A, it moves to point B and moves to point C back. Last class I have told you students, please don't confuse, this is not the actual path. Actual path is taking on the x-axis. That means it starts from this position 1, it goes to this position which is B, and then comes back to this position which is C. In this question we have to find the average speed and average velocity given that the time it takes to move from A to B is suppose 1 minute, and the time it takes to move from B to C is 4 minutes. So this is the question, and the x value is given in meters. So before finding average speed and average velocity, first we should find, students, distance and displacement. So distance in this example will be how much? Distance is nothing but path length. The total length of the path, that is from A to B, that is AB, plus from B to C, that is BC. How much will be AB plus BC? A to B is how much? That is 1 units, 1 meter, plus what is B to C? B to C is, you can see from here, 1, 2, 3 units. So 3 meters. That is how much? 4 meters. So this is the distance traveled by the body. So AB plus BC is equal to 4 meters. Here when the question is being asked, you have to find average speed and average velocity. Let me write the question here. Find average speed and average velocity for entire journey. What is the meaning of entire journey, students? It means you have to consider the motion starting from the initial position A to the final position C. So for the total journey I have found the distance. Now let's find displacement. Displacement I have told it is path length, it is the relative position of final position with respect to initial position, and it is given by the formula final position, which I write as XF, F for final, minus initial position, I for initial. Now what is the final position, students? The final position is at C and the initial position is at A. And if you remember, I have told you for finding displacement, forget about the path. Just see where is initial point, where is final point, and join the two positions using a straight line. Initial point was here, final position is at C, that is here. Join this by a straight line pointing from initial to the final point. That gives you the value of displacement. So XF is how much? Final position you can see it is -1 minus XI. What is the initial position? Initial position is 1. So this becomes how much? It becomes -2 meters. Here also you can see this is one step and this is second step. So it is 2 meters. But since it is to the left, that's why it is minus. You can also write it like this, that displacement is 2 meters to left of initial position. Okay. After finding distance and displacement, next step will be to find average speed, because we have been asked to find average speed and velocity. The average speed, you know, students, what is the formula? It is the total distance by time taken. Total time. Now what is total distance? That we have already calculated, that is 4 meters. Now what is the time taken? Time taken is the time elapsed for the entire journey, that is from A to B and from B to C. It is clearly 1 minute plus 4 minutes, that is 5 minutes. This you can convert in SI unit. 4 meters by 5 minutes you can convert in seconds, and then you can calculate, you will get some meter per second. Now how to find average velocity? Average velocity, you know the formula, that is given by displacement by time. What is the displacement value? It is -2 meters, where minus is not for the magnitude. Minus means it is to the left. Let me encircle both of them. Minus means to the left. Here also minus means to the left. By total time we have seen 1 minute plus 4 minutes, that is 5 minutes, is equal to -2 meters by 5 into 60 seconds. So this you can calculate. This becomes -1 upon 150 meters per second. You can add one line. This means its value, the average velocity is 1 upon 150 meters per second towards, where, students? Towards left. If you get positive value of average velocity, you can write there it has direction towards right. So this is one example for discussing distance, displacement, average speed and average velocity. Okay, students. Now on the screen you can see there are 4 physical quantities which I have written: distance, average velocity, displacement, average speed. Let me recapitulate the things which we have discussed so far from you. Tell me, students, out of these 4 quantities, which are scalars and which are vectors? Scalars means they are not associated with any direction, they have only magnitude. Yes, the first one is simple. This is scalar. I'll write S for scalar. And displacement is, yes, you have guessed correct, that is vector. Now in the formula for average speed, we have distance or displacement. Distance, average speed is distance by time. Distance was a scalar, that's why average speed is also scalar. Displacement was vector, therefore average velocity, which is displacement by time, will also be a vector. Remember these two quantities which are vectors, it can be positive, it can be negative, it can be zero. Likewise, this can be positive, it can be negative, it can be zero. But distance and average speed, they cannot be negative. So they are non-negative values. Average speed is also non-negative. These things you must remember. Whenever you are finding in a question about displacement or about average velocity, they can have minus sign. No problem in that. That minus will simply indicate about direction. Okay. Next topic that we will discuss, students, is about uniform motion. You know the literal meaning of uniform. Uniform means something which remains constant with time. It does not change. It does not change. Uniform motion is that motion in which the velocity vector is constant. When I say constant, I mean it has constant value, it has constant direction. Constant in both magnitude and direction. Suppose there is a body which is moving like this in a straight path with a speed 2 meters per second, and it moves from point A to point B, and at B it takes a turn to point C, but its speed remains 2 meters per second. Now here you have to understand, students, that the motion from A to B, this motion, it is uniform. Why it is uniform? Because the direction from A to B is fixed. Also, the value of the speed or velocity is also fixed. Likewise, the motion from B to C is also uniform. This motion is also uniform. Same reason, because direction is not changing, it is moving in a particular direction and the value remains fixed. But the motion from A to C, what about this? Here we find the value of speed or velocity, it remains 2 meters per second, it does not change, but its direction changes at some point, and therefore we will say motion from A to C is not uniform. Why it is not uniform? It is not uniform because the direction of velocity has changed. This is first example. Second example, suppose there is a body which moves in a particular direction. It does not change its direction. It is moving at a speed of 1 meter per second starting from A. It moves to point B. At B, it increases its speed, and from 1 meter per second till this point, its speed was how much? 1 meter per second. Now it starts increasing his speed and continues to move in the straight path till his speed becomes 4 meters per second. Here the speed is increasing. Somewhere the speed will be 1.5 meter per second, somewhere the speed will be 3 meters per second, and up till 4 meters per second it increases. Now can you guess, students, which part of the motion has uniform value? Which part of the motion is uniform? This part from A to B is uniform motion. Why it is uniform? First, the direction of motion did not change, and second, the value of velocity remains same. But from here to here, the motion is non-uniform. Why non-uniform? Because the value of velocity 1, 1.5, 3, 4, it is changing continuously. That's why this motion is non-uniform. I have seen two examples. I have discussed two examples. Here, the motion from A to C is not uniform because there is change in direction of velocity. And here this part B to C, it is non-uniform motion because there is change in value of velocity. So if you combine this, for uniform motion, the required condition is that velocity should be constant in both magnitude as well as direction. Direction will be constant only if the particle is moving in a what kind of path? A straight path. It cannot bend. So if a body moves in a straight path with constant speed, you can also write velocity without turning, without changing the direction, then its motion is said to be uniform motion. Is it clear, students? This is a very important concept. So in one statement, in one sentence, if you are asked define uniform motion, you can simply say motion of a body is said to be uniform if its velocity is constant. You can elaborate it. It means it should have both constant magnitude as well as constant direction. Let us see one more question. The average speed of a particle from point A to point B is v1. From this point to this point, it moves with average speed v1. And from B to C, it moves with an average speed v2. You have to find average speed from A to C. Students, I would request you to pause here for some time, think about its solution, and when you have thought, you have tried to solve, then you can continue watching this video. Okay. We have to find the average speed from A to C. We know the formula for average speed. From A to C, the average speed I will write as VAV. Average speed formula, you know, it is total distance divided by total time. Here one data is given to you, students, regarding these points A, B and C. Here it is given that BC is twice of AB. Different data can be given. Some questions you might find B is at the center of AC, then AB will become equal to BC. Here it is given twice of AB is equal to BC. I forgot to give that condition, so this is given in the question. Now average speed, we have written the formula total distance by total time. Total distance is how much? Total distance is A to C and total time is suppose T. I will assume A to B distance to be X. Then as given in the question, BC is twice of AB, so this B to C will become how much, students? Twice of X. Next, I will assume the time taken to move from A to B, that is from this point to this point. I will take this time as T1 and I will take the time to move from B to C, this time I will take it as T2. So the total time which I need here is nothing but T1 plus T2. Now what is the total distance? AC? AC will become AB plus BC. But how much is AB? It is x. And how much is BC? It is 2x. So it becomes x plus 2x. So our answer becomes 3x upon T1 plus T2. Now here x is okay, but T1 and T2 we have to find. For finding T1 and T2, let us see the motion from A to B. And then we will see the motion from B to C. For this motion A to B, I will use the formula average speed. Now from A to B, average speed is given V1, so I will write V1 is equal to distance from A to B, that is how much? X, by time from A to B, that is given how much? T1. Likewise from B to C, what is the average speed? It is given V2. What is the distance? Distance is twice of x. And what is the time? Time is T2. We will find T1 and T2 from these two equations and put in this equation. So this implies, what will be T1, students? T1 will be x upon V1. And from here, what will be T2? T2 will be 2x upon V2. Put the values of T1 and T2 in this equation. So average velocity will become how much, students? 3x divided by T1. Instead of T1, how much we should write? X upon V1. And instead of T2, we should write 2x upon V2. X I can take common. Is equal to 3x divided by x, you will take common. What will be left? 1 upon V1 plus 2 upon V2. You can see, students, x will cancel. Rest is mathematics. You can take the LCM. Is equal to 3 upon 1 by V1 plus 2 by V2. We can take LCM V1 into V2, and this will become V2 plus 2 V1. And therefore, the average speed from here, you can write how much? Average speed V average will become how much? 3 times V1 V2 goes up upon V2 plus twice of V1. So in this way, we can solve problems pertaining to average speed, average velocity, distance, displacement. Whatever examples I have discussed today, please go through them properly and try to solve some questions from your NCERT students. I am giving you the task for today. From NCERT, you see page number 100 and page number 102. Here in these two pages you will solve the blue ink questions. They are specially marked in your NCERT. Apart from this, also you try to solve some examples which are solved in the book. You can solve examples 8.1, 8.2 and 8.3. I understand, students, that after solving some problems, I suggest you to solve more problems from other texts, from exercise also. You might develop some doubts also. So to help you out, for your queries, you can send in your queries. If you get some doubts, you can send in your queries to the email ID jiwan924@gmail.com. I'll try to figure out the problems arose by you, and we'll see if we could discuss in the next class. So I thank you once again, and I hope you will come prepared in the next class. Thank you.